Hello, everyone. Thank you for joining DataCon LA 2021. Welcome to the Data for Good track. My name is Eli, your host, and our co-host today is Murali. We will be moderating the chat and Q&A for you during the session. Today, we have our guest, Anand Ranganathan, who will be presenting Exposing Public Data Through Natural Language and Conversational Analytics. He is a co-founder and the Chief AI Officer at Unscrambl. He is a leading Unscrambl product development. He's leading Unscrambl's product development in several cutting-edge areas, including natural language processing, automated insights, data storytelling, and real-time optimization and decision-making. Before joining Unscrambl, he was a master inventor and research scientist at IBM. He received his PhD in computer science from UIUC and his BTech from the IIT Madras. He also has 70 academic journal and conference publications and 30 patent filings in his name. Without further ado, I'll hand this over to the speaker. Thanks for being here, Anand.
No, thanks, Eli. Thanks, Murali. Thanks everyone for staying. I believe I'm one of the last talks in the conference. So, but I always enjoyed coming and presenting at DataCon either virtually in person. I even managed to dig up, an old Big Data or DataCon LA shirt from 3 years back and decided to wear today's talk. But yeah, so today I'll be talking about a new paradigm that we've been developing that we call natural language and conversational analytics, where we allow people to explore data sets through natural language queries, which mainly at this point is English queries, but other languages are possible as well. And we believe it's can dramatically improve data adoption and data democratization, both in the private sector and within enterprises as well as for the general public. And that's where we see lots of good opportunities for data for good use cases. So the problem we're tackling is that data adoption remains pretty low these days, both enterprises as well as the general public. In the enterprise space, only 31% of businesses say that they're data-driven, and that's actually been coming down over the last few years. And there are different reasons for this, right? Most users find it very difficult to access data. They either need to know, they don't have the right skills to access data. It might take them too much time because they don't know where the data is located. It could be spread across different silos or different data sets owned by different parts of organizations or externally. And finally, in terms of skills, it's you might need to know Python or SQL or the query languages. You might need to know how the data is actually modeled and structured in a database data warehouse before you can actually make sense of it. So it's often difficult for the general public, non-technical users, to find data of interest and get insights from it. So lots of data is being collected both within enterprises as well as general public. So even this conference, I think I've listened to a bunch of talks where people are making use of open data sets. The city of LA had a bunch of talks where talking about everything from data about checkbooks, all finances, to other public data sets. So there's lots of very interesting data sets that's being collected out there. And there are good tools as well for data scientists, data analysts, or more technical users to analyze the data. And again, this conference, we've seen a whole bunch of talks on that topic as well. But the challenge remains is that most decision makers or business users, the people who actually need the data to decide what to do, don't have direct access to the data. So we call this a last mile problem. So even the data is available and there are tools for some kinds of users to access data, most non-technical users cannot really consume the data easily. So while there's plenty of great data sets out there, one good example is a COVID data set, right? So there's great data sets being maintained by a bunch of organizations like JHU and Johns Hopkins. There's New York Times data set, which I think has been, at least one of the talk was using that data set for some purpose. The Wall Street Journal. So there are lots of different data sets on COVID today. But in spite of all that, there's so much misinformation and lack of awareness of the impact of COVID, both nationally as well as within communities. So in general, availability of data is not enough or collection of data is not enough for general public to get actionable insights and take informed decisions on the data. And this is not just in COVID, right? There's lots of data sets that are being collected around different topics on transportation. There's a last talk was around data sets being collected and used from City of Glasgow, I think. Data sets about weather, about statistics, climate change, financial data sets, and so on. So there's a lot of data out there, but still, it's difficult for most users to actually access it. So most people, general public, as well as in enterprises, they get the data from pre-built dashboards or sometimes news stories. Right? So they rely on others essentially to create, or more technical users to create dashboards or create reports or write news articles, and then that's the medium for them to consume data. So it's always somebody between these users and the actual data. So there are a lot of challenges around dashboards. So a dashboard or report might not support drilling down into the data in different ways. Most people may not know how exactly the data for the dashboard is prepared from the raw data. You can't ask a very different questions. So each dashboard essentially answers one specific question, but if you want to ask something different, you're out of luck. And the most tricky thing about dashboards, as well as news articles, is that they are more opinion pieces somehow than actual facts. So it's easy for a dashboard creator to cherry pick the right stats or figure out the right way of visualizing the data to advance some opinion of theirs. Right? And while that's fine for some cases, it can be misleading as well. And it's very easy to create fake stats and fake news and spread that around these days. So I almost think of dashboard creators as being artists, where they take the raw data, they make a painting essentially to convey their opinion about the data, but then the public would look at that dashboard and think that's the truth, right? And it's difficult for them to prove otherwise. So while as we struggle with getting access to data, the whole BI space, the BI analytics, business intelligence analytics space, has been moving towards something we call the age of the augmented consumer, where the consumer of the data has more powers in exploring data and understanding what the data really means, and in coming up with interesting insights that they can take actions on. So different properties of being an augmented consumer of data. So oftentimes the data is in these tools in the latest tools are presented as data stories, where you can converse the data in natural language. There's more natural language explanations of what data is available. The data can also be personalized, and the analysis insight can be personalized for the user's needs. The data is often more real time. And one thing that's pretty important from our point of view is collaboration, that different people can collaborate while exploring and analyzing and understanding what data means. So that's what we mean by the age of the augmented consumer. And so this is a chart from Gartner where they've shown data, this whole BI space evolving from semantic platforms, semantic layer-based platforms in the early 2000s to visual exploration platforms in the late 2000s or late 2010s. The mid 2010s had this notion of augmented analytics, and now it's the augmented consumer. So I'll just spend one or two slides talking about what we've been building at Unscrambl. So our solution to solving this last mile problem of data consumption by non-technical users is we want to allow people to explore and analyze structured data through natural language conversations. So we have a bot called Cubo. Cubo stands for Query Bot or Question Bot, where users can ask questions of data in English. Behind the scenes, Cubo is going to be able to connect to different either internal enterprise-specific or external open public data sets. Users can then converse with Cubo while they explore this data. And also different users can collaborate with each other while exploring the data. So one of our mission is to make data be available within chat platforms. So today we have an integration with Microsoft Teams, but over a period of time, you want to have data be, you can ask questions on data on other platforms as well, like Slack, as well as WhatsApp and instant message, Facebook Messenger, and so on. So we want data to be conversational, where different users can just ask questions to a bot about data and get interesting answers. So some examples of kind of questions that people might want to ask on data. So for instance, with the whole topic of climate change, you might be able to want to ask questions like, what's the average number of forest fires in California yearly? Or compare the trend of COVID cases in California versus Texas. or how many violent traffic stops in Connecticut were there by race in a given year. So those are questions. There are different open data sets where you can answer, where these questions can be answered. But if you had these kind of questions, you would actually have to actually download the data, find the data sets, download it, and then use SQL or Python or some other tool to get the answer to these questions, which could take anywhere from an hour to maybe even much longer, depending on your skill and availability of data. So um, so the whole idea is that we want people to be able to ask questions, and then a bot will be able to understand these questions, convert these questions into queries or the analysis on data, on database, data warehouses, or other data sources, get back the answers and present it meaningfully back to the end users. I just see one question coming
Yeah.
up.
Yeah, if you want me to ask them out loud to you at any point, I could do that. But so how are you differentiating from Google's Lambda? That's the question.
I'm trying to remember what Google's Lambda is. I'm actually doing it quick.
Sundar Pichai had launched that, right? It's a new NLP, natural language processing, which is Lambda. I don't really know what it stands for, the acronym, but they also have very similar things. Sundar Pichai had showcased. So I just wanted to know, how is Unscrambl differentiating its product from Google's Lambda?
Right. Yeah. So our main differentiator is that we are very is that firstly, behind the scenes, we're focused on questions against structured data. So typically these are data in database, data warehouses, or even just CSV files or Excel files. And behind the scenes, what goes on is the conversion from natural language to SQL. So it's a very specific kind of natural language processing. I think Lambda has a more general take and not necessarily focused on analyzing data sets from what I remember. And the other thing is that we are very highly configurable. So the same tool, well, most of the tools tend to be more general purpose, where they'll have one NLP model for asking all kinds of questions. That's how Alexa, Siri, and even Google Home and all those, they have one universal model. But in our cases, we want to train a different model depending on data set. So if your data set was on climate change and forest fires, there's one NLP model that's trained on that data, and that data
Okay.
can be configured. If your data set was on COVID, there's a separate NLP model that will be trained for answering specifically COVID questions on COVID. And it's configurable as well. So because very often the way you ask a question in natural language, like number of forest fires and so on, could be very different. And the way the data is represented in database could be very different. So in the database, there might be a code for forest fire, and you have to translate, when I say forest fire, maybe it's called FF in the database. So that kind of mapping is something which we've seen is critical to let users ask questions naturally. Because very often data is stored in databases oftentimes in a very is optimized for other reasons, for storage or for efficiency of queries, but not necessarily for making it easy for users to ask queries in natural language. So we have some configurability properties where you can train and configure and train natural language processing model specifically for a given data set. So yeah, that's sort of the very high level.
Thank you.
Yeah. So this whole and this is kind of a fairly new space, and Gartner's called this conversational BI and analytics, or conversational chatbots for analytics. The whole idea is that we want to allow users to ask text or voice questions of the data in English and receive back a natural language or visual analysis of all the relevant insights or actionable insights for that user. And so this is a newly burgeoning space. It's got a few companies that are trying to make progress in this, and but at least we think it's the way of the future. So I'm actually going to show a demo to give you an idea what this looks like, and hopefully this. So this is our web interface, and you can try this out. We have so if you go to our website in cubo.ai, you can actually, there's a trial available where you can upload your own data sets or point to your own data sources and try to ask questions. But let me show you what this looks like. So in this particular example, I've actually loaded up a database containing FEMA data on disasters as well as assistance that FEMA provides for, in the case of disasters, either through housing assistance or through or flood insurance or other programs that FEMA has. So that's the basic data set here. It is kind of topical given all the extreme climate events that have been going on lately. So the way you ask questions to the data is through conversations. So there's a bot called Cubo, and I can create a new thread. And they say I call this thread demo. And then I can, there's some hints on, that I can say, get me started to provide some hints on what kind of data is available. And so make a data over there. And here is saying that there's data about disasters, there's data about national flood insurance claims, there's data about housing assistance. In fact, this particular demo has two data sets. One is a cricket data set. I won't focus too much on that, but as for the disasters data set. So one of the goals of the system is to allow people to ask different questions on diverse data sets, and the system figures out what you're asking and how to answer it. But I'm going to focus on the disasters questions. So I can ask questions like, say, total number of FEMA, let's say, disaster declarations yearly. And so the idea is, asking this question in plain English, and the system is able to understand this question and come back with an answer. So I'm going to zoom in over here to the answer that's come back, and it says for each year how many disasters were declared by FEMA, essentially. Right. I can also look at the actual SQL query. So behind the scenes, for most questions, either one or more SQL queries might be generated. In this case, it's one query. And we see the actual query that was generated. And this is generated automatically. And we get an idea of what are the tables that were hit and what were the filters and so on. I can also change this into different chart types. So like any BI tool, if I don't like a table view, I can look at it as a line chart. And one thing that you might notice here is that the number of disasters declared by FEMA has actually been growing steadily, with a dramatic peak in 2020. So maybe I find this interesting. So the whole idea is, we want people to be able to explore data themselves. And when they find something interesting, we want them to, consume data. So one of the common themes these days is using tools, in apps like Pinterest and Instagram. You can create your own board, or create your own, and Pinterest is you can pin charts to a board or images to a board. So we have a similar concept where you can pin a chart to a board. And let's say I found this interesting. This is my board that I'm going to preserve. I can explore further on the board, or I can add, or I can keep refining my natural language. So another differentiation with many other tools is that we are conversational. So I can dig deeper and say, show me by incident type. So now it's going to interpret this question incident type in the context of the previous question. Whenever there's any ambiguity, it's going to ask me for clarifications. So now I get back a new data set, which has the number of incidents of different types for each year. So 1953, there was 1 fire, 5 floods, 1 other, 6 tornadoes. 1954, there was 1 earthquake, 7 floods. And again, I can also change this back to a line chart. I can add this to a board, and this gives us some clues of what happened in 2020. So while that's being added up, so in 2020, we see that this is one big dot over here, that there were actually 8,026 disasters declared by FEMA of type biological. And so that's most of those are pandemic related. So that's almost a new category that FEMA created last year. So, and that probably explains, why there was this a big peak in 2020. But the whole idea is now you can just ask question natural language and keep exploring data. Given that this is, DataCon LA, let's ask some topical questions around California LA, which I think fires is one of the key disasters in California, right? So let's say we ask a question like top 5 states in order of the number of fires, right? And so this is now giving which states had fires coming of declarations of fire-related disasters by FEMA, the top 5 of those states. And now there's two ways of interpreting this question. So the word fire appears in a couple of different places in the data set. One is in an attribute called incident type. and the other is in a declaration title called fire. So so in this case, because natural language is by definition ambiguous, we're trying to explain to the user the two ways of interpreting this particular question. So let me say incident type fire, and then we see what our top 5 states. So surprisingly, I think Texas actually has had far more fires in the last 50 years than California, and then the states after that are Florida, Oklahoma, and Washington. And so let me add that to the board as well. Maybe just throw in a few more questions just to explore that fire data in a bit more. Maybe ask a question like number of fires in California yearly. And again, it's asking whether I want incident type or declaration type. Let me say incident type. And then here again, we see a dramatic increase in the number of fires declared by FEMA, especially starting from the early 90s. And 2020 had 65 fires. Let me add that to the board as well. Maybe we need to be more specific as well. So let's say fires in Los Angeles. So fires in Los Angeles in, let's say, the last 5 years. And here there are a few different ways of interpreting Los Angeles. It's asking the city, the county. So let's say number of disasters in the county of Los Angeles of type fire in the last 5 years, or what are the disasters, right? So it's actually now listing the different fires that have occurred in Los Angeles County in the last 5 years. Let me zoom in a little bit. Full screen. So maybe some of you might be familiar with these different fires of the last 5 years. Old fire, fish fire, sage fire, and give some information about when it started, when it ended, and so on. Let me add that to the board as well. But yeah, so that's sort of the basic idea of the system, where you can, we have this data set out there. There's, if you had knowledge of Python or SQL or other tools, you could download this data and explore it, but most people cannot or not able to do that. So our goal is to help those kinds of users in exploring this kind of data sets. So yeah, so let me, the other thing that a system can do is actually also automatically explore the data to come up with interesting findings. So I have predefined dashboards where the system is automatically exploring the data and coming up with interesting findings. So we have anomaly detection algorithms as well as association rules, trend analysis, and so on, where the system is going to explore the data and come up with findings. So one of the findings that it came up with on its own was Florida surprisingly has a large number of freezing disasters. And it sort of explains why. So it's saying that there were 147 freezing disasters. There have been 147 freezing disasters in Florida, which is much higher than many other states. So the next state, in fact, is California with 57. Even though hurricanes is the biggest, but there's a strong association between Florida and freezing. And then some of the other interesting associations: California with fires, we explored that; Louisiana with coastal storms; Maryland with snow; New Mexico fires, and so on. Another finding that it came up with that I found pretty interesting was that Iowa, even though it's kind of in the Tornado Valley alley and a Midwestern state, tends to surprisingly have much fewer tornadoes and fewer duration of tornadoes than most other states around it. Total claims paid for flood insurance in Minnesota is very low. So essentially, beyond the user interacting with the bot by asking questions, the bot can also uncover interesting findings and present them back to the user.
I have a question about about the data and how it's learning these things. Is it sort of like an encoder decoder model where you've got like it learning the data behind the scenes, but also learning the language that people might ask about the data? Or what exactly is happening?
So there are also pieces to this. So you're right, that part of this problem is that we do have an NLP model which does have at a very high level encoder decoder architecture, actually more like a transformer architecture, where it will translate natural language to SQL. or in general to even in some beyond SQL, also to some Python-based modules. But the other piece, which is critical, is the actual, we call the semantic modeling of the data, where data analyst, data scientist might provide some hints to the system saying that these are tables of interest and these are key definitions that you might be using. That helps in bridging the gap between users and data. So, for example, in this example, the disasters database, there were 5 different tables. There's a disasters table, a flood insurance, a couple of flood insurance tables, a hazard mitigation table, and so on. Let's say the disasters table had so many attributes, and these are different attributes. And some of the things that, so some of this information is automatically available from the schema in the database. But an analyst or end user, or particularly a data analyst or database administrator, will provide a bit more information provides a bit more information to the system to help it understand exactly what is the data that's being stored in the database. So in this case, for instance, it's saying that disasters is of type object and not a person. Each individual row in the database or the table is an individual disaster, as opposed to an aggregation of disasters, which typically happen in data mart. There are some synonyms. So the primary keys are place code and FEMA declaration string. So even if the actual end database does not have a primary key, the primary key information is very useful for us because it helps us understand how to frame queries appropriately. A synonym of this disaster table is disaster declaration. So these are different definitions that help our system understand the data better. Also, you could specify joins. You can specify some special kinds of tables. So one of the ways many databases model data is using something like many-to-many relation. So if you have many-to-many relation, you can define that over here. So this is where part of the magic happens. Part of the way for the system to understand what exactly is the data that's being used to what exactly is the meaning of the data of the different tables and different attributes in the tables and definition of metrics and so on. So this in conjunction with the encoded transformer architecture is what's used behind the scenes to transform natural language to SQL. Then the SQL is sent to the database, you get back the answer, and you present it back to the user. Present results back to the user. But let me actually switch over back to the slides. So talk a bit more about some of the things that go on behind the scenes. So firstly, what are the key properties here? A lot of things actually go on behind the scenes. So a part of this is natural language understanding to understand what the user is saying, but there's lots of other elements in the system. So firstly, there is the notion of natural language understanding queries in English. Oftentimes, the queries are ambiguous and poorly formed. Many users, even technical users, do not actually frame queries in a clean way that maps to the data and database. So they might just use terms or use phrasings which don't correspond to SQL queries. So a big job is figuring out how to handle ambiguity or poorly formed queries, and also understand these queries in the context of a conversation, because very often the question you're asking might be pretty differently depending on your previous queries. So that's one aspect. The second aspect is understanding the semantics of data. So that's what I was talking about, that beyond just doing the natural language understanding and producing SQL, you need to produce SQL in a way that is consistent, or that's appropriate for a given database. So one analogy I often give is that this is like machine translation, where you might but it's not translating, say, English to French, English to Spanish. You're translating from English to million possible varieties of French, where each database is its own French, essentially its own SQL. So we have to produce SQL in a format or using SQL that's correct for a given database, right? So that's where the semantics of data becomes important to understand how to produce the right SQL. Right. So then the next question, next place where to make some innovations, how best to present and explain the results to the user. So beyond getting the data back, you need to now figure out the right way of visualizing it, whether it's tables or line charts or bar charts, and even natural language to explain what's the data is actually saying. Uh, Collaborate with the user to define the data, and learn the user's preferences in jargon continuously, proactively generate interesting insights. So the other properties of the system as well that all come together to allow conversational, or what do you define as conversational analytics. So behind the scenes, let's see what happens, right? So when you set this kind of system up, so this bot Cubo acts as a middle person or middle layer between users and possibly multiple data sets, right? So there's today we support 20 different kinds of databases, data warehouses, even Excel sheets. And oftentimes, and the way this is all is set up is that firstly, a data modeler or data or administrator would configure the system, point you to the right databases, and add additional semantic or ontological information about the data in that database. And then the system will train a natural language processing model for that data specifically. And then that model is then used to understand users' queries, produce the right SQL or several SQL queries, send that query to the back. Then the bot sends the query to the backend database, assuming it's the translation is not ambiguous. The bot sends the query to the database, gets back the answers, and presents those answers using combination of charts and natural language. So that's sort of the way the system is architected.
Just to let you know, we have about 10 minutes left.
So, yeah, that's be fine. I only have a few more slides. So let's see some of the key parts in the natural language processing itself, right? So there's different elements over here. So this is a different example from a different use case. So let's say ask a question like number of trips in winter 2017 by age and gender. So this is actually on a bike share data set where actually if somebody is familiar with this is using city bike data from New York City. So let's say that's the data set in question. And let's say somebody had a question like number of trips in winter 2017 by age and gender. So let's see some of the key pieces involved there. So one of the challenging problems is figuring out how to segment or how to partition this sentence into different entities or construct different entities so as to then be able to find the key elements of the SQL query. So in this example, the key entities of interest are number of trips, that's some kind of aggregation, filter in winter 2017, and by age and gender. So those are the key elements, right? And it's a non-trivial problem to figure out where to do the splits, right? So we have to first recognize entities and construct entities. So there are some similarities to the name recognition space that natural language processing is pretty has deep into, but we had to there's lots of other advances you have to make to figure out how to do this segmentation in a consistent and robust manner. So once we do this, then we have to figure out, based on the segment entities identified, what's the kind of query that we need to make to the database. So in this case, you might say that, okay, fine, this looks like an aggregation query where we need to find, say, a count as an example here. And there are some filters and groupings over here. So there's a filter, there's a filter like in winter 2017, there's a couple of group bys by age and gender. And then we might do some more mapping. Maybe the raw database does not have an attribute called age. So we need to define or derive age from, let's say, a birth year. Right? So we need to also then figure out how do I interpret winter 2017. So maybe winter 2017 has to be further understood as some date range. Maybe say in this case, December 23rd, 2017 to March 19, 2018. Right? And then gender is maybe there's an attribute called gender database. So there's a lot of mapping, and this is where some of that semantic modeling needs to occur, because we need to figure out how, with the right user hints, how do I derive age from birth year, or is there a standard definition of winter that should be used in a certain context? Because this winter in the US is very different from winter in even in Europe, for instance. They have often different date ranges in mind. So that whole semantic modeling is critical to make the right translation. So once we do this, then there's again that's this, and we might need to then figure out how to generate the right SQL query. So in this case, some of the things we need are for doing a count, where we're grouping by age group and gender, and doing a where clause for the actual time filter, and also computing age from birth year. So all that is happening here. And finally get the results, figure out, okay, what's the best way to visualize this? Maybe in this case, it's this kind of heat map chart, and then show this as back to the user. So it's just a slight deeper dive into what goes on behind the scenes to answer this kind of query. So yeah, actually, that's actually my last slide, and hopefully, given you a glimpse of what we think is the future of data, or future data exploration, using natural language and conversational analytics. And feel free to try this out. And also, I'm here to take any more questions, or any more questions come on later. Feel free to reach out to me by email or by LinkedIn. So thanks, and let's see if any questions.
Anand, the Cubo.ai, is that a time limit for the trial period, like 14 days, 30 days, or?
Yeah, there's a 14-day time limit, but depending on the case, we can we can increase it for anybody who wants to try it out for longer.
Yeah.
So, who do you envision are the main types of clients that will be using this system? Do you feel like it's the people writing the articles, or do you feel like it's the public, or what?
Yeah. So right now, our primary, as a startup, we're doing money, but as a primary audience tends to be enterprise users. So we have a version of this that can be installed or used by enterprises and pointed to their data sets. So we have customers, for instance, in banking and insurance, various industries where there are users in enterprise who might ask questions about sales or revenue or prices or invoices, supply chain, logistics, so different data sets that they can ask questions on. So that's our primary user. But one of the things we've tried to figure out is, at least for me, this personally would be very interesting for me to figure out, is how this can also be exposed to the general public in interesting ways. So we do have a couple of public demos, and we also have the trial version available for users to upload their own data sets, point to their own data sets, and start asking questions. But we're still figuring out exactly what's the right business model for making this more universally accessible to the public. Maybe partnering with the governments, with state or local governments, to have those same data sets like the city of LA has, make it accessible for natural language. So we're still figuring it out. But yeah, we think the users could be either a combination of semi-data literate people who know enough to be dangerous to ask interesting questions on the data, as well as people who may not know how to ask questions, but maybe through observing others or through other social channels, they might figure out how best to answer questions on data. So
you have a similar question that came up. Would a basic user need technical help setting up the app? And where is your data coming from? But I think the first one is about the users.
Right. So it's in our mind, there are two kinds of users of the system. So you definitely need technical expertise or some knowledge about the data to set the system up, right? So imagine this forest fire or the public data set that's on FEMA that is set up, right? So somebody who knows the data is the one that's setting this up. But once it's set up, then anybody, even who doesn't know the data very well, can start exploring it, right? And without hassling, or without depending on somebody else to create a report or dashboard or chart or other news story, right? So they can create their own news stories or create their own dashboards by exploring data themselves. So so we see two kinds of users: the people who set the system up, who need to be familiar with the data in a deep way and understand at least some basic principles about data modeling and ways people can ask questions. And then the general public or people who are less technically savvy, and then those are the ones who might benefit a lot by asking questions in natural language. So there's the admin data modeler role, and then there is the end users who are asking questions in natural language. And the second question, I think, on where's data coming from. So this is more a platform. It's not anybody can. You can set up an instance of this platform, point it, or either upload or point it to any database, whatever it could be of any topic, and start asking questions. So we ourselves are not creating data or selling data in any way. We're more providing this tool that allows people to point to any data and then ask questions on data.
So we're out of time now. So thank you very much, Anand, for your presentation and for the attendees for questions and interactions during the session. You can contact the speaker directly, as he said, if there are any further questions regarding this topic. Please provide your feedback using the form that I'm going to put in the chat box. And thank you again, everyone, for joining today's presentation. And I hope you've gained some insights from the session. Have a wonderful day, and thank you for being a part of this year's DataCon LA.
Thanks, Eli. Thanks, everybody.
Thank you, Anand. It was a great session.
Thank you.